We're going to start by working on a couple problems with you guys today in your homework just to make sure you're on the right path. I'm going to do problem number 1 and also problem number 7. So let's take a look here at problem number 1. In problem number 1, you're going to be converting and finding the percent composition of mercury oxide, specifically the mercury and the oxygen. We have to assume 1 mole because we don't know the exact amount given to us. This is a theoretical problem. In other problems, we may be given exact amounts and we have to use the exact amounts. So let's begin. First, I'm going to list each of the elements, mercury and oxygen. Then I do a quick count of how many times they occur. Mercury occurs once, and oxygen also occurs once. I'm going to multiply them by their respective atomic masses. Mercury has an atomic mass of 200.59, and oxygen has an atomic mass of 16. You can round a little bit, but try not to round too much. Multiply them both by there and get a total amount. We're ultimately just finding molar mass. So mercury currently weighs 200.59 total, and oxygen is 16, and then I'll add each up. Together, they end up being 216.59. This happens to be the molar mass of mercury oxide. Now that I have this total, I'm going to divide each individual by the total mass. So 200.59 divided by 216.59. And then I'll also work on oxygen. 16 divided by 216.59. And this will get me two small decimal numbers. Once I resolve this, I end up with 0.9261 and also 0.0738. I multiply each of these by 100% to convert them to percentage, and then I'll know the percent of mercury and oxygen in this compound. Mercury ends up being 92.61%, and oxygen ends up being 7.38%. To do a quick check to make sure I did this right, they should add up to something close to 100%. These happen to add up to 99.99%. That's extremely close. We did the right job. What's the actual answer? The actual answer that I'm looking for is the individual percentages of the elements. So mercury actually is 92.61% of this compound, and oxygen is 7.38% of this compound. Those are the answers I'm looking for. And the second problem I'll work with today, we're going to try to solve for the percent composition of calcium hydroxide. It'll be ultimately the same method, we just have a few extra elements to worry about this time around. So we're going to assume 1 mole again because we don't have a real amount. With that in mind, I'm going to list each element. I have calcium, I have oxygen, and I also have hydrogen. I do a quick count of each. There's only 1 calcium total. There are 2 oxygen. Make sure you multiply. And there are 2 hydrogen. That 2 is a multiplier for both the oxygen and the hydrogen. Multiply them all by their respective atomic masses. Calcium has an atomic mass of about 40. Oxygen is around 16, and hydrogen is around 1. All of these are very close to those individual whole numbers, so I'm safe without rounding a little bit. Multiply each of these, and I get a total calcium mass of 40. Oxygen ends up being 32, and hydrogen is also 2. Add them up like the previous problem, and you have a total atomic mass of 74 grams. I'm going to divide each of the elements by this 74 grams to work my way towards the percentage of each individual element. 40 divided by 74, 32 divided by 74, and 2 divided by 74. This will get me a very small decimal number. From there, it's just one quick step. I have 0.5405, 0.4324, and also 0.0270. Multiply each of these by 100%. It's an easy step at this point. The final percentages, calcium will be 54.05%, oxygen will be 43.24%, and hydrogen is 2.7%. These are my final answers. I can do a quick check to make sure they add up to something close to 100%, and these also add up to 99.9%. We did the right thing again. Once again, box my final answers. The 99% is not an answer I'm looking for, it's just a check. So we're going to box calcium, oxygen, and hydrogen's individual percentage. And that's the final answer for number 7. Now, for the rest of these, you'll do the same method with the exception of the last one. The last problem I'm going to leave to you. This one involves real amounts. This is not assuming a 1 mole. You have to assume exactly how many grams you have. From there, you find out the individual percentages. You do know exactly how much of each element you have in the last problem. Divide it by the total mass present and find those individual percentages. I'm going to go ahead and post the second half of this for Monday in the upcoming days. These will be a little bit more complex than the ones you just did.